Okay, we are doing section 6.4 on solving compound inequalities. A compound inequalities consists of two separate inequalities and they are either joined by the word and or the word or. Now an and inequality will always be written as 1, like -2 is less than x, which is less than or equal to 1. And if I was to graph this, it's an open circle at -2 and a closed dot at 1, and the line would be in between. Okay, so graphing it, they come together. This can also be called an intersection graph because they intersect in the middle. Now an OR graph is written as two separate inequalities, like x is less than -1 or x is greater than or equal to 0. And the way this would look is -1 open, that's going to be going to the left, and then closed at 0, arrow going to the right. Those are never going to intersect, they're always going to go in opposite directions. This is called a union. The way I want you to remember them, though, is by the and or the or. Translate the verbal phrase into an inequality, then graph the inequality. All numbers are greater than -2 and less than 3. So there's our keyword and. That means we're going to write it as one inequality. So I always like to write it in numeric order. I think it makes the most sense that way. If all real numbers are greater than -2, that means our -2 is less than x. And when we have an and inequality, the inequality symbols, when you write it as a string, are always pointing the same direction. So this less than 3, that would be correct because they're pointing the same way. That's an open circle at both of them, -2 and +3, and the graph would come together. All real numbers that are less than 0 or greater than or equal to 2, that means that we can already just write it as two separate inequalities. Numbers that are less than 0 or greater than or equal to 2. And then graphing this, the 0, the arrow would go to the left, and the 2, the closed dot, that would be going to the right. A crane sits on top of a camera car and faces toward the front. The crane's maximum height is 18 and the minimum is 4. Write and graph an compound inequality that describes the possible heights of the crane. So whenever we have temperature or height and we're talking about a range, that's always going to be inclusive and it's always going to be an and inequality. So we are including 18 and we are including 4. So if I'm going to write an inequality that represents this, it would be h is greater than or equal to 4 and less than or equal to 18. And we can just leave it like that. So then on our graph, here's 4, here's 18, closed at both, and since it's an and, they're going to come together. And that makes the most sense that a height difference would be an and inequality. Okay, now we're going to be solving, not just graphing compound inequalities. So this is an and, which we can tell because it's written as one inequality, a string of it, and we need to get that x alone in the middle before we can graph it. So just like solving regular equations or regular inequalities, we want to get that x alone. So we need to subtract 5, but this time we're subtracting 5 from all three sides. 2 minus 5 is -3. 9 minus 5 is 4. And there's our solution. This one is multi-step. We need to subtract 4 from all the sides. Rewrite, and the y is still not alone in the middle, so we need to divide everything by 2 because that's what is connected to our y right now. 6 divided by 2 is 3. 20 divided by 2 is 10. And since now that we have the y alone, we can graph it. Okay, so to get that x term alone, we need to add 3 to all three sides this time. Don't forget to include the negative x. And now we're not quite done because we don't want to know what negative x is. We want to know what positive x is. So we need to divide all three sides by -1 to get that x alone. And when we're dividing by a negative or multiplying by a negative, we need to switch the inequality symbol as well as the signs. Greater than or equal to x, greater than or equal to -5. Remember, I always like to rewrite it in numeric order. So I would rewrite this as -5 is less than or equal to x is less than or equal to 2. These are exactly the same. Closed at -5, closed at 2, and so it's inclusive. Okay, here's an or, so we need to solve both of them separately. We don't have to solve all three at once this time. So I'm going to subtract 3 from both sides of the left inequality. Then we have 2x is less than 6. Divide both sides by 2. X is less than 3 is one of our inequalities. On the other side, we're going to add 6 to both sides. Divide by 3. X is greater than 6. So x is less than 3 looks like that. And x is greater than 6 looks like that. Okay, this is an and because it's written as one string. I'm going to subtract 2 from all three sides. -3 is less than or equal to -5t is less than or equal to. Then I'm going to divide all three sides by -5, which means I have to flip the inequality symbols. 3/5 greater than or equal to t, greater than or equal to -2/5. And I will always rewrite my answer in numeric order, which is -2/5 less than or equal to t, less than or equal to 3/5. -2/5 is right about here. 3/5 is right about here, and we are inclusive. Here we have an or, so we just treat it like two separate problems. Okay, so when we graph this, it's going to be closed at -1, arrow to the left, and open at 4, arrow to the right. Okay, last page we have a problem about the Mars exploration rover. There's two robots that were sent to Mars in 2003 in order to gather geological data about the planet. The temperatures at the landing sites of the robots can change from -100 degrees Celsius to 0 degrees Celsius. Write a compound inequality that describes the possible temperatures in Fahrenheit at a landing site, recalling that Celsius is equal to 5/9 times Fahrenheit minus 32. So if we know that our temperatures are from -100 to 0 in Celsius, we need to substitute this in for C because we want to represent this in degrees Fahrenheit. So -100 is less than or equal to 5/9 times F minus 32 less than or equal to 0. And in part B, we need to solve it. So I think the easiest thing to do here is to divide everything by 5/9, which is multiplying by 9/5. That gets rid of the 5/9. The only number that really changes here is the 100, changes to -180. And then I'm going to add 32 to all three sides. So -148 is less than or equal to F is less than or equal to 32 degrees. Those are our Fahrenheit temperatures. And we need to then graph it. Here's negative 148, here's 32. And identify 3 possible temperatures at the landing site. We could pick anything between negative 148 and 32. So how about negative 100, negative 50, and 0. You could pick any 3 numbers in that range that you want. And that is our section 6.4 on compound inequalities.